Okay. Let's do this problem here. And then, yeah, try to see if we can solve this. So basically, let's design a circuit code. Design your implementation of a circuit code. The circuit code is a linear data structure in which the operation performed in FIFO principle and the last position is connected to the first position to make a circle. One of the benefits of a circuit code is that we can make use of the space in front of the queue. Okay. In a normal queue, once the queue becomes full, we cannot insert the next element even if there was space in front of the queue. But in a circuit queue, we can use the space to store new values. Okay, that makes sense, I guess. So by using the circle, we can use initialize the object with the size of the queue, or to be k. Gets the front of the queue. If the queue is empty, return -1. Gets the last item in the queue. If the queue is empty, return -1. Insert element into the queue, return true if the operation was successful. Deletes an element from the circuit clue. Oh god. It has to be the last one, right? Yes, okay. Checks whether the circuit queue is empty or not. Checks whether the circuit queue is full or not. Okay, so full is basically if it reaches capacity. Okay. So, we can probably say store the capacity. Store a head pointer and tail pointer. And they're going to point at each other. Or more specifically, when I NQ, so it's going to be like, yeah, these are just pointers, so they're not actual values. So yeah, I would always pop from the head pointer and insert at the tail pointer. And first I'm going to also yeah. Okay, first I also need to make a linked list, like a node at least. So we'll do that too. Create a node class. We'll have value, next, and should be good enough, I think. Okay. And yeah, that should be pretty simple, okay? For the methods, obviously for front, should return the head dot next. For the rear, return tail. I guess maybe having, okay, instead of a previous, we could do that too. Dot previous. I think having a previous would be relatively helpful. Like a doubly linked list, double-ended linked list. And then obviously if you want to insert values, we will insert them to the like, okay, so we have this, right? Note, like, we'll have the head. So the head previous actually would go goes to tail. I'm gonna put it like this. tail. They go backwards, that back and forth, right? The previous for the tail is head, and the previous dot next is obviously head. Same thing. Let's say I add a value. I want to put node 1. We'll do node 1 here. So if we want to insert, then the if we want to insert, then we'll do do I even need a... Actually, I don't even think I need a tail. I just need the head, because... yeah, because I can just go previous, right? Right? Then I do node 2, right? So the previous, right, is going to point to node 2. Previous, so it's going to... So it's going to do head dot next is this. Yeah, so, okay. So to have it, the idea, this is the head pointer. And then we'll add values. So I'm going to add node 1. Right? Then node 2. Let's do like 3 values, right? Or let's do 2 values. We'll do 2. So we'll do like a ring buffer, right? Oh, no, I can't do... No. Yeah, I think this works. So it's like a ring. So this kind of goes like this. So that's what I'm thinking. Do I need a head or tail? I feel like I want to have a tail, but do I even need a tail? I don't know. Do I really need a tail? Honestly, I don't know. This doesn't make sense at all. So we have these, right? H1, 2, right? But if I had a tail, right? Like a head, tail, and then they just kind of wrapped around like this, right? They're always like touching each other. And then I had like this, 1, 2, like that. So they're like wrapped around. So if I say head.previous would be the last value, head.next would be the first value. And every time I want to add a value, I add it at the end. So I do tails here, and then dot previous would be this. Oh, get this guy, the next for him will be the new value. The previous would be point like this, and that's how we add it. And to pop, we just get the next value here, and you're gonna point like that, and this guy dies, and then previous points back here. And then yeah, I think that's more helpful. I think, in my opinion. Just 1 second. I think that's a solid plan. So let's have a head and front reads, yeah, like this. These are just mainly pointers. They don't represent any kind of value. Is empty. How do we check is empty? Is empty. Check if tail dot previous equals head. That's pretty simple. Is full. That means if k. Check if k is at 0, or cap is at 0. I think I cover all the cases that I can do. DQ, that's the front rear, and then we just do, okay, NQ, add, adjust pointer at head, adjust pointer at tail, at head at tail. So yeah, I think this covers all the scenarios. So let's first make my class implementation of class list. Let's call it node. It needs to be weird. All right, I fucking hate this stupid thing. Okay, well, no, that's fine. And then our constructor here, we'll do the value, previous and next probably. Oh, we'll have default values, so I don't have to like do that. So we'll do self.val equals val, self.previous equals previous, self.next equals. So, okay, I clearly think that is not a good one because straightforward, basic node class, very simple. Okay, in this thing we'll need to create self.cap, which is going to be our k, and okay, then we'll do our self.head, which is going to be a list node, or not a list node, a node, which is going to be well, it's not going to take anything. I probably should pass in nothing, right? 0, none for now. Do the same for this. Well, right, previous, and then next, or okay, because the previous should be the self.head, right? And then we will then the next will be also self.tail or head. How about this? I'll put them as defaults for now. Well, okay, actually, since they're gonna be always like that, I don't need to do that because I already have defaults. Okay, actually, yeah, let's just create the nodes. And then self.head.next is equal to self.tail. Self.head.previous is equal to self.tail. Self.tail dot next is going to equal self.tail.next is equal to self.head. Self.tail.next equals self.tail.previous equals self.head. Pretty straightforward construction. We're basically starting off like this, you know. We have a head pointing at each other. Tail. Let's call it T. Easy peasy. Okay. Enqueuing. So we're entering a value. Entering value should start from the tail. So we'll do node. We'll call this node here with the value of this. We'll specify the stuff for now. Then node. Okay, so the way we do this, we'll do okay. So we'll need to update something. We'll do from the tail. So self.tail. So we're saying it's more like this. It's like, okay, let me specify this. It's a bit confusing when I say it's bidirectional. It looks like a graph. It's not really a graph. It's more like, okay, head.next is like this. Tail dot next is like this. Previous is like, okay, let's say this is next is like this, and then previous is like, it's like it wraps around like that, and then next is like this, and then previous is like this. That's more what it is, to be honest, right? Next is like this, and then previous is like that. So next, yeah, next, previous. So basically I need to update the previous. So self.node or self.tail.previous. Who am I pointing at, right? So that's, yeah, that's that previous, right? Then we'll say previous.next is equal to node, right? Node.previous is going to equal previous, right? Node.next. Oh no, did I fuck everything up actually? GG's, boys. Actually, if I change it like that, everything will be fine. Okay, so I get the previous, so which is going to be like our head here. I'm going to point this not to tail now, point this to the new node. Then I'm going to take the node, this new node here. I'm going to point this guy's previous to look at head, and I'm going to point this guy's next to the tail to equal to self.tail. And the I want self.tail.previous to equal to node. Okay, does that make sense? That was a lot of reorganizing. And then return true. Okay. Does that even make sense? So let me like walk this through right here, right? We have here, oh crap. Okay. So we're saying take this. So we have the node. Create the new node. So previous is going to equal self.tail.prev, right? Uh-oh. Okay, but we're good. Yeah. So it can be self.tail.prev, right? Then prev.next equals node. So yeah, I'm basically pointing who is this guy, what is the last value? This is the last value. Let's call this last, right? Last, right? Let's call this last node. Last node. Okay. Then last node.next equals to so let's say right now this guy is going to be the last node technically. We're going to say, okay, we're going to say the next pointer to that is going to be, we're going to unlink this, we're going to delete this, we're going to point this guy's next to be this guy. Then I'm going to take the node.previous, right, this guy's previous to this guy. Like this. Then I'm going to say the next is going to equal this guy. And then I'm going to also update the tail.previous, self.tail.previous. To equal like this. And boom, we entered it in constant time. So yeah, okay. Now DQ, that is going to be the opposite. So now let's say we want to get rid of this guy. So basically, let's call this first node, which is going to equal the self dot head dot next, right? We have that node, and then we're gonna say we're gonna say, okay, so we're gonna say the self dot head dot next is equal to the first node dot next right? The first node dot next. So we're gonna say the first node dot next. So we're saying, okay, so we got this guy, right? Let's call this 1. We're saying, okay, this is one pointer, and then we'll say the head dot next. This guy is gonna point to this guy dot next. So basically the neighboring values. So we're gonna point to. Don't do that. Point to this guy. I still have some pointers to do here, so I should probably get the next node, which is first node dot next, and then we'll say next node, and then we'll say next node dot previous, right? We're gonna do the previous so basically it's already pointing at it. Oh shit. The previous. Oh god, I just realized something. Wait, this shouldn't exist anymore. Yeah. Previous points like that. Next. Wait, okay, so previous points this way. His next will be like this. This won't exist anymore. Right? It's more like so the next for the tail is going to be the head. And then the previous for the head is going to be the tail. That will never change. But the next and the previous for the tails, so then the next for the head is going to change, and the tail for the previous will always be changed to like the new values. So actually, is empty. We can just simply write if self dot head, right, head dot next equals self dot tail. I think that's kind of a case that makes sense in my opinion. Okay. Okay, now back to the DQ. So how can I DQ this? Also, hold on. I need to do this. Self.cap. Yeah. Also, hold on. Let's check. If self.cap. Oh, I think we can say if if self dot is full, right? Return false. Self dot is full is pretty simple. If self dot cap equals 0, or just return self dot cap equals 0. Simple. Okay, then now what was I trying to do here? DQ. Okay, so now I need to say the first node is this, right? So I'm saying, okay, get the first node, get the next node, so this dot next here, right? And I'm gonna say, okay, the head dot next is now gonna point to whatever this guy is, right? So we'll do that. I see. Then I need to update this guy's tail. Yeah, the tail, or not the tail, the previous of this guy, which I have by next node, by pointing to me. So self dot head. And then so we point this guy to here, and boom, that's it. We don't give a shit about that guy. Return true. DQ. Okay, so operation was successful if that happens, but there's a case that it could be. Okay, also I'm probably gonna do self.cap increment by 1. Also, I guess we could say if self dot is empty, return false, I guess. I don't know. How do we check if it's empty? We already did that. It's full, easy peasy, lemon squeezy. Okay. Okay, now front. Simple. We just say return self.head.next, return self.tail.previous, and okay, .val. I guess if Q is empty. Okay, so if self dot is empty, return -1, and the rear if self dot is empty, return -1. Easy. Okay, let's test it. No. Oh. Brother. So here. Anything else? Invalid syntax. What the? I thought I got rid of this. Any more stupid invalid syntax, bro? Previous is not defined? Oh shit. Huh? Oh. Oh yeah, what the fuck? Wait, what am I saying here? So we're saying, okay, to enqueue it, so I have last node, right, which is basically self.previous, yeah, and then the last node dot next is equal to the current node. Then I'm gonna say the that doesn't make sense. The previous is going to equal Okay, I have a problem. Never mind. Okay, I want to enqueue. So how do I do that? So it's like this. Head. There. Okay, we have the next, the previous, tail. I want to enqueue something. So I want to do this. The next is gonna go like this. The previous is going to go like. The previous is going to go like this. So like that. That's how previous goes. Call this prev, and then we'll call this next. So basically, I need to point the previous for tail, right? So first, check if it's full. So node equals that value. So I made the value, but it doesn't point to anything, right? Then the last node is basically this one, which is this guy. Then I say last node dot next is going to be like this. Point this guy to here. And then I do node dot previous is equal to okay. Okay, that's what I meant. I meant to say last node, right? Because this was the last node. Yeah, last node dot next. So this guy's next value is this, and this guy's previous is this. So we make that connection, right? Then the self dot tail dot next node dot next. We make this connection. Then we make the self dot tail dot prev new connection to this. Boom. We've enqueued it. We used up space, so decrement and then return true. Okay. Beautiful. That's exactly what we needed. All right. See you guys tomorrow.